If Excel says external data connection failed right when you hit refresh, you're not alone. The good news is most refresh errors come from a small set of predictable causes. The trick is to stop guessing and identify which layer broke: Excel, the connection, the driver, the network, or the source system. Once you know the layer, the fix is usually quick. In the next few minutes, you'll learn a practical checklist that works for SQL connections, ODBC data sources, and web queries. We'll start with the most common error patterns, then move into credentials, privacy and permissions, driver mismatches, and query timeouts. I'll also show you how to capture a useful error message, so you're not troubleshooting blind. And we'll finish with prevention, how to make refreshes more reliable for you and for anyone else who opens the file. If your workbook is business critical, this approach can save hours of repeated failures. Let's start by decoding what Excel is actually telling you. Next step. First, separate the message you see from the cause underneath it. External data connection failed is often just the wrapper. The real reason is usually in the detailed error text from Power Query, the ODBC driver, or the database. So your first goal is to reproduce the failure once, then capture the exact wording. Look for clues like authentication failed, timeout expired, could not find driver, or name not resolved. Each phrase points to a different fix path. Authentication means credentials or permissions. Timeout means performance, blocking, or network latency. Driver errors mean bitness or missing components. Name resolution points to DNS or a changed server address. If the error mentions privacy levels or firewall, that's typically a Power Query setting. If it mentions ODBC explicitly, think DSN, driver, or connection string. Treat the error like a map. Once you categorize it, you can troubleshoot in the right order instead of trying random settings. Next step. Next, figure out what type of connection you're dealing with, because the tools differ. Classic Excel connections include ODBC, OLEDB, and older web queries. Newer workbooks often use Power Query, even if you didn't realize it, and refresh happens through that engine. A quick way to think about it is your data coming into a table through a query or through a legacy connection? SQL Server imports might be either. An ODBC connection might rely on a DSN, which is a named data source on the machine. Web queries might be a simple URL fetch or an authenticated API call. Why does this matter? Because a DSN can work on your computer and fail on someone else's. A Power Query can fail due to privacy settings, even when the database is fine. And a legacy connection might store credentials differently than Power Query. So before changing anything, write down source type, server or URL, and whether it refreshes for other people. Next step. Now let's hit the most common cause, credentials. Refresh often fails because Excel is using an expired password, a different Windows account, or cached credentials that no longer match the server. With databases, you might be using Windows Integrated Authentication or a database username and password. Integrated Auth can break when you're off the corporate network, on VPN, or using a different domain context. Database logins can break when passwords rotate. Web queries fail when tokens expire or multi-factor prompts can't be completed during automated refresh. The fix is to update the credential store used by the connection. In Power Query, that means editing data source settings and clearing or changing permissions for that specific source. In legacy connections, it may mean re-entering the password in connection properties or rebuilding the connection string. Also check whether the workbook is trying to use current user versus a saved credential. If refresh works for you but not a colleague, it's often a permissions difference on the source side, not Excel itself. Next step. If credentials look fine, the next layer is permissions and access rights. A database can accept your login, but still deny access to a table, view, or stored procedure used by the query. That shows up as permission denied, invalid object, or the select permission was denied. In SQL environments, access is often granted through roles, and roles can change without warning. Another common issue is that the query references a schema name that differs between environments, like dev versus prod. For ODBC sources, you can also get blocked by file permissions if the data is actually a local or network file behind the DSN. For web queries, you might be allowed to open the URL in a browser, but blocked from automated calls due to IP restrictions or missing headers. The practical move is to test the same query outside Excel using a database client or a simple ODBC test tool. If it fails there, it's not an Excel problem. If it succeeds there, focus back on Excel's connection settings and credential handling. Next step. Let's talk about ODBC driver and bitness issues, because they create confusing failures. Excel comes in 32-bit or 64-bit, and ODBC drivers also come in 32-bit or 64-bit. They must match. If you have 64-bit Excel but only a 32-bit driver, your DSN might not even appear, or refresh will fail with driver-related messages. Another trap is having multiple versions of the same driver installed, like different SQL Server native client versions or multiple PostgreSQL drivers. Excel might pick a different one than you expect. DSNs are also separated by bitness, meaning a 32-bit DSN is invisible to 64-bit Excel. The fix is straightforward. Confirm your Excel bitness, then install the correct driver version. If you rely on DSNs, create them in the correct ODBC data source administrator for that bitness. If you can, prefer a DSN-less connection string inside the workbook, because it's easier to move between machines, but it still requires the driver to exist. Next step. If the error mentions timeouts, you're dealing with either slow queries or slow connectivity. Excel refresh has multiple timeout points: the database driver, the query engine, and sometimes the server itself. A query that runs in 10 seconds in a database tool can still time out in Excel if Excel pulls more rows, applies transformations, or refreshes multiple queries at once. Blocking is another big one. Your query waits because another process is locking tables. For web queries, timeouts often happen due to rate limits, slow endpoints, or large downloads. The practical fix starts with reducing the workload. Filter earlier, select only needed columns, and avoid select star on large tables. If you're using Power Query, push steps back to the source when possible, so the database does the heavy lifting. If you truly need a long-running query, increase command timeout where supported. But treat that as a last step, because longer timeouts can hide performance problems and make refresh feel unreliable. Next step. Web queries fail for a different set of reasons, and the biggest one is that a URL is not always just a file download. Many endpoints require headers, cookies, or an authentication flow. If the site redirects from HTTP to HTTPS, or from one domain to another, Excel may treat it as a different source and block it. Certificates can also break refresh, especially on corporate machines with inspection proxies. Another common failure is that the response format changes. Your query expects JSON fields or an HTML table, but the site returns a login page, an error page, or a different schema. The fix is to validate the endpoint behavior. Does it require sign-in? Does it redirect? And does it return the same shape every time? For APIs, use stable endpoints and versioned URLs when available. If you need authentication, prefer methods that support non-interactive refresh, like API keys or OAuth tokens that can be renewed. And keep an eye on rate limits, because repeated refreshes can trigger temporary blocks. Next step. Power Query adds one more unique cause: privacy levels and the Formula.Firewall. This typically shows up when you combine data from multiple sources, like a SQL table plus a CSV file, or a web API plus an Excel table. Power Query tries to prevent accidental data leakage between sources. When privacy levels are mismatched, refresh can fail, even though each source works by itself. The error text often mentions Formula.Firewall, or that the query references other queries and can't access the data source directly. The fix is to set privacy levels consistently, or redesign the query so the combination happens in a controlled way. Sometimes that means staging. Load one query, then reference it from another. In other cases, it means changing the privacy setting for a source from private to organizational, if that matches your environment's policy. Be careful here. Lowering privacy protections can have real data governance implications. The goal is a refresh that's both reliable and appropriate for your data sensitivity. Next step. Another sneaky category is connection strings and endpoint changes. A refresh can fail because the server name changed, the database moved, the port changed, or DNS alias was retired. With ODBC, the DSN might still point to an old host. With SQL, you might be connecting to a named instance that no longer exists. With web queries, the path might change, even if the domain stays the same. You'll often see errors like server not found, could not open connection, or name not resolved. The fix is to validate the endpoint outside Excel. Can you reach the server name from your machine? If it's SQL Server, can you connect with the same authentication method using another client? If it's a web endpoint, can you fetch it without being redirected to a login? Then update the connection definition in one place. If your workbook contains multiple queries pointing to the same source, standardize them so you're not updating 5 different connection strings later. Consistency is a reliability feature. Next step. Sometimes refresh fails because of how Excel is trying to refresh, not because the source is broken. Background refresh can collide with other operations, especially when multiple queries load into the data model or pivot tables update at the same time. You can also get failures when a workbook opens and immediately tries to refresh before the network is ready, like right after waking from sleep or before VPN connects. Another issue is concurrency. Refreshing several queries in parallel can overload a database or trigger API rate limits. The fix is to control the refresh sequence, turn off background refresh for critical connections, and refresh in a deliberate order, staging tables first, then dependent queries, then pivots. If you distribute the workbook, consider disabling refresh data when opening, and instead use a manual refresh step or a control button macro if your environment allows it. The goal is predictable refresh behavior, not maximum automation at any cost. Next step. If you're still stuck, you need better diagnostics, because the default Excel pop-up is rarely enough. Start by isolating. Refresh one query at a time. If one fails, you found the culprit. If all fail, suspect credentials, drivers, or network. Next, simplify the query. Remove steps until it refreshes. Then add steps back to find the breaking point. This is especially effective with Power Query transformations like merges, custom functions, and type changes. For ODBC and SQL, copy the final SQL statement and run it in a database client to confirm it works and to measure performance. For web queries, capture the exact URL and verify the response content type. Also note whether the failure happens only on one machine. That points to drivers, DSNs, or local policy settings. Good troubleshooting is boring on purpose. You change one thing, test, and keep notes. That's how you avoid going in circles and accidentally breaking a working connection. Next step. Let's finish with prevention, because the best fix is the one you don't have to repeat. First, document the source, server, database, authentication type, and required drivers. Second, avoid machine-specific dependencies like DSNs when you can, or at least standardize DSN names across your team. Third, design queries to be resilient, filter early, keep transformations minimal, and avoid brittle parsing of web pages that can change. Fourth, separate staging from reporting. Load clean tables first, then build pivots and charts from those tables, so one failure doesn't corrupt everything. Fifth, plan for credential rotation. If your organization rotates passwords, use authentication methods that support it cleanly and know where credentials are stored. Finally, add a simple last refresh time cell so users can tell whether data is current without guessing. Reliable refresh is a mix of good connections, good query design, and predictable refresh routines. Next step. So when Excel external data connection failed hits, don't treat it like a mystery. Treat it like a layered system. Start with the exact error text, classify it, and work from credentials to permissions to drivers to timeouts to endpoint changes. Control refresh behavior so Excel isn't tripping over itself. And once you fix it, lock in the prevention steps so the workbook stays stable when it moves to another machine or another user. If you want a simple rule, it's this. Make the connection predictable, make the query efficient, and make the refresh process deliberate. One last thing before you go. If you had to choose, which type of connection fails you more often, SQL ODBC or web queries? Share your answer in the comments as A for SQL ODBC or B for web. And if you want more practical Excel troubleshooting checklists like this, subscribe. I'm always testing new ways to work smarter. Subscribe to see what workflow I'm breaking down next.